Okay, in 7.4, we start talking about similar triangles again, and more about what we can do with their proportions and side lengths and stuff. So it's really important that you remember from 7.1 through 7.3 how we were doing proportions. So if you have something set up like this, you're going to cross multiply to solve. So this would be 30 times x minus 5 equals 20 times x plus 3. And then you'd have to do your fun algebra, distribute, move the x's over, and combine like terms and solve for x. So that's what we're going to be doing more today. We're going to learn 4 things today. Again, use properties of similar triangles to find segment lengths, and apply proportionality and triangle angle bisector theorems. So 4 things that we're going to talk about today. First thing, triangle proportionality theorem. If a line is parallel to a side of a triangle, and that parallel side intersects the other 2 sides, then it's going to divide those sides proportionally. So if we have a triangle, like we do here, and they tell us that these 2 sides are parallel, automatically this triangle will be similar to this triangle, and their side lengths will be proportional. So if I tell you that 2 sides are parallel, what's going to happen is this side AE over EB will be proportional to AF over FC. So if I give you something like this, and I tell you that this is parallel to this one, and let's say this is side length is 3, and this side length is 9, and this side length is 4, and this side length we don't know, you can set a proportion. So 3 over 9 equals 4 over x, and then cross multiply and solve. Okay? So that's the first thing, triangle proportionality theorem. They have to tell us that those lines are parallel. So over here they want us to find US. We could say that that's x. Since these are parallel, these 2 triangles, this small triangle and this larger triangle, will be similar. So we could say 14 over x equals 10 over 4, and then cross multiply and solve. So 10x equals 56, divide by 10, x equals 5.6, or US equals 5.6. All right, so again, they have to tell us that these sides are parallel, and then we can find a missing side length, a missing segment of this similar triangle. Again, some of you guys might be thinking, well, wait a second, why are these in even similar triangles to begin with? Well, if we have parallel lines, that means that we're going to have corresponding angles. So these 2 angles will be congruent to each other, and n is congruent to itself. So in this small triangle, we have 2 similar angles, or congruent angles, and in the larger triangle, we also have 2 similar angles, angle N and angle M, angle N and angle Q. So by angle-angle similarity, that's why we can set up this proportion to begin with. So there's lots of ways you can set this up. You could say x over 3 equals 5 over 2, and then cross multiply and solve. Okay. So that's the first thing that we're talking about. The second thing is the converse of the triangle proportionality theorem. Converse means we just flip whatever it is that we were doing. So before, the first thing I had to tell you was that these 2 sides were parallel, and then we knew that the sides would be proportional. Converse means we're going to flip it. If I know that these 2 sides are proportional, that means we can conclude that this side is parallel to this side. So we're just doing basically the opposite of what we were just doing. So verify that DE is parallel to BC. We want to prove that this one is parallel to this one. So all you have to do is set up a proportion. 10 over 15, is that the same as 8 over 12? You guys can reduce and say, well, let's see, I can divide both of these by 5. So that would be what, 2/3? And I can divide both of these by 4. And oh my gosh, it's 2/3 as well. You could reduce if you want to, or you can cross multiply and say 10 times 12 is the same thing as 8 times 15. So it would be 120 equals 120. Or you could just pop it into your calculator and say 0.66 repeating is the same thing as 0.66 repeating. Either way you want to do it, either one of those 3 things, as soon as you figure out that they're the same, then you can say, ta-da, they are parallel by the converse of the triangle proportionality theorem. So same thing over here. They tell you AC, so this whole thing is 36, and BC, this whole segment, is 27. We want to prove that A, B, and D, E are parallel to each other. So if this whole thing is 36, that means, and this part's already 20, that means the leftover has to be 16. The same thing over here. If this whole thing's 27 and the leftover is 15, then what do we get? 8 or something? What's 27 minus 15? 12. Okay, I was way off. Sorry. Okay, so then we do the proportionality. So you could say 16 over 20 equals 12 over 15. You could cross multiply. You can reduce 16 divided by 20. I'm just going to pop it in my calculator. 0.8, and 12 divided by 15 is 0.8. So we could prove that these two are parallel. So those are the first two things that we're doing in this section, 7.4.